What if I told you that a problem costing manufacturers thousands of dollars every year can often be traced back to a component that costs less than a simple service? And what if that same problem is slowly damaging your air compressor right now, while you don't even realize it? Because here's the reality. Air compressors rarely fail without warning. They whisper before they scream. They run a little hotter, consume a little more electricity, trigger the occasional temperature alarm, and then one day, they shut down completely. Production stops, deadlines get missed, customers get frustrated. And management starts asking one question: what happened? The shocking truth is that most overheating problems are not caused by catastrophic mechanical failures. They're caused by restricted airflow, poor ventilation, dirty filters, and increasingly by something many maintenance teams overlook: using the wrong compressor oil or extending oil change intervals far beyond the manufacturer's recommendation. These simple mistakes silently turn your compressor into a pressure cooker. And by the time the shutdown happens, the damage may have already begun. Today, we're going to uncover the #1 reason air compressors overheat, why it happens, and how a few simple maintenance checks can save your business thousands. The marathon runner analogy. Imagine running a marathon wearing a heavy winter coat. Now imagine someone placing a plastic bag over your head and asking you to keep running. Your body is generating heat. But that heat has nowhere to go. Your temperature rises, your performance drops. Eventually, your body forces you to stop. Not because you're weak, because it's protecting itself. Your air compressor works exactly the same way. Every time it compresses air, it generates massive amounts of heat. That's normal. Heat is part of the compression process. The problem begins when the compressor loses its ability to remove that heat efficiently, and that's when overheating starts. The silent killer, hiding in plain sight. Most facilities assume compressor breakdowns happen suddenly. They don't. Overheating is usually a slow-moving problem that develops over weeks or months. The compressor room starts feeling warmer. Energy consumption gradually increases. Maintenance costs creep upward. The machine seems to run longer than before. Pressure delivery becomes inconsistent. Temperature alarms begin appearing occasionally. Most people ignore these warning signs until the day production stops. Then the investigation begins. And what do technicians often discover? A clogged intake filter, dust-covered cooling surfaces, blocked ventilation grills, poor room airflow, or oil that should have been changed months ago. The compressor wasn't failing, it was suffocating. Why airflow matters more than most realize? Your compressor survives because of one critical process. Heat enters, heat leaves. Fresh air enters the system. Heat is transferred away from critical components. Hot air exits. The cycle repeats continuously. Now imagine interrupting that cycle. Dirty filters reduce incoming airflow. Blocked vents trap hot air. Dust-covered coolers prevent heat transfer. Poor ventilation causes hot exhaust air to recirculate. Instead of removing heat, the compressor begins recycling it. Internal temperatures climb. Components operate under greater stress. Efficiency drops. Energy consumption rises. And eventually, the machine shuts itself down to avoid catastrophic damage. The shutdown isn't the problem. It's the compressor trying to save itself. The overheating cause nobody talks about: wrong oil and delayed oil changes. Here's where many facilities make a costly mistake. Even when airflow is perfect, overheating can still occur. Why? Because compressor oil doesn't just lubricate moving parts, it also removes heat. Think of compressor oil as the machine's bloodstream. It carries heat away from critical components, it reduces friction. It protects bearings and rotors, it prevents excessive wear. But when the wrong oil is used, everything changes. Low-quality lubricants can break down faster under heat. Incorrect viscosity can reduce cooling performance. Some oils form sludge. Heat transfer becomes less effective. Internal friction increases, operating temperatures rise, and the compressor runs hotter. The same thing happens when oil changes are delayed. Over time, compressor oil becomes contaminated with moisture and carbon particles. Its cooling efficiency declines, its lubricating properties weaken, the compressor must work harder, more friction creates more heat. More heat accelerates oil degradation, and the cycle continues until overheating becomes inevitable. Many think they're saving money. In reality, they may be accelerating equipment wear and increasing energy costs. Saving a few dollars on maintenance can cost thousands in repairs. The real cost of overheating. Most people focus on repair bills, but repairs are often the smallest part of the problem. When a compressor unexpectedly shuts down, production stops. Employees wait, orders get delayed, customers lose confidence. Emergency technicians are called. Replacement parts are expedited. Managers spend valuable time firefighting. Revenue opportunities disappear. Now ask yourself, how much does 1 hour of downtime cost your facility? For many manufacturers, the answer isn't hundreds, it's thousands. And all of it can originate from a dirty filter, blocked ventilation pathway, or neglected oil change. The 4 biggest overheating culprits. Number 1, dirty intake filters. A clogged filter restricts airflow and forces the machine to work harder. Think of breathing through a drinking straw while running. Possible? Yes. Efficient? Not even close. Number 2, Blocked cooling vents. Storage boxes, pallets, and poor layout decisions often block cooling airflow. The machine simply cannot breathe. Number 3. Poor compressor room ventilation. Many rooms become heat traps. Without proper fresh air circulation, the compressor continually recycles hot exhaust. Number 4. Incorrect or neglected compressor oil. Using the wrong lubricant or extending intervals reduces cooling and accelerates wear. This is often overlooked. Final takeaway. If your air compressor keeps overheating, don't immediately assume you need a major repair. Start with the fundamentals. Check the filters, inspect ventilation pathways, clean cooling surfaces, evaluate room airflow, confirm you're using the correct lubricant. Because in most cases, overheating isn't caused by a catastrophic failure. It's caused by a simple maintenance issue that was ignored for too long. Remember, your compressor doesn't suddenly fail. It gives warnings. The question is whether you'll listen before the shutdown happens. Because sometimes the difference between maximum productivity and costly downtime comes down to something simple: clean airflow, proper lubrication, and preventive maintenance.